Time for another DraftScience video presentation. So, various subjects, overview video, sort of. Some effort to convince you that the conventional model is well underdeveloped, way overhyped, way under evidenced, and that the only reason why it survived is because an alternative wasn't provided, a better theory. Generally speaking, a more complete answer wasn't found, and the simple answer, tends to be the one that people, the easy to say anyway. You can say it in a couple of sentences. It's almost like the God thing, right? You can just say God, and then you can end the conversation, and it almost doesn't matter what kind of nonsense you invent as the reasoning for the God, how he makes his heaven, or why he makes these certain choices about what kind of, rewards you're going to get and why you're going to get the rewards. More important that you're baptized than if you don't kick old ladies, that kind of stuff. What sins get forgiven? Anyway, I don't want to get into a religious argument, but science is victim to the same kind of human frailty, of quick judgments. I want it now. I don't, answer now, kind of stuff. The future doesn't matter. It gets into a whole nother philosophical conversation, about the inefficiency of expediency and how it creates waste and mistakes. And you could argue, certainly I would argue, that physics made a bunch of those. I guess I should move this up a little because they seem to be not staying where they were. Anyway, so the simulation is still, it's still broken, but it's very close to being very good. And so clearly development of the atoms and all the rest of it, and very simple rules for how it interacts with the force. And so it'll just be a matter of changing ratios, perspective to illustrate magnetic effects and electricity and the development of atoms and all of that crap. Energy and momentum, all of it will be eventually modelable and showable, and it'll be a convincing piece of evidence for some, no doubt. But till then, these arguments should be somewhat convincing, I think, to some regular people. Just the fact that physics has really made a mess out of physics, made a mess out of defining our reality. And they've done it with stupid things like, making comparisons to water and light, and then making comparisons between solar systems and atoms, and, trying to do all of this simple stuff, try to make it, make the rules consistent when, they're a little inconsistent just because of the size ratios and stuff. The big universe isn't, in a sense, is duplicating the small universe, but you have to understand on what principles it's duplicating it. The laws are the same, and why do the laws manifest a little different in the big one than in the small one? But you have to understand that the small one is fundamentally different than the big one, and that the small one is the only universe. So that's one of the first statements I guess I would write as a statement. Now, I did Google that phrase just to see if anybody else ever said these words, in this order. The small universe is the only universe. Now, maybe somebody said it in some other way. That's, to me, the simplest way of saying it. That whatever happens, all of this happening stuff, happens on the nuclear level first. The little bits have to make it happen. They're doing the work. Atoms don't move. The stuff inside the atom moves. These kind of rules. And, all these little bits of force and energy have to move around. before anything happens. And that's just, all of it is just small universe first. And following these really dumb rules. I mean, very simple rules. Very, no room for anything elaborate going on here. We are, in fact, just computing devices. We are calculators that the universe invented through evolution. And, that's all we are. You punch in the numbers and we pop something on the display. That's it. Actions and reactions. So it's just, it's one of those things, if you believe me, or you believe with me, that the small universe is the only universe, it has a whole bunch of implications, and especially related to the idea of determinism and cause and effect. And if you believe in cause and effect, and that the small universe is doing it all, it's just a matter of figuring out, rules that allow it to do this evolving, for patterns and complexity to be preserved and to survive, arrangements, to become durable, like the arrangement of the 100 atoms, the periodic table, the durable arrangements of electrons and protons, and there's only 100, basically. Anyway, all right. It's the speed of force, not the speed of light. And I should Google that and see if people get that one. Now, the speed of force comes up because there's a movie reference now. Apparently, one of the Marvel comic things or something is using the speed of force. And so there's a million references, but I just wonder how many people said the speed of force before that came along. Because it's really another important insight into how the universe works, is that all of the stuff happening, gravity and magnetism and electricity, which are the same thing really, charge, it's all happening at the speed of light, which is the speed of force. Light is just one of the forces. It's just one of the manifestations. The second line says it. All forces are varieties of one force. It's all one force moving the speed of force. And all you can do to create these different manifestations is to change the pattern of the force, because the force actually does have a varieties. It comes in the red and the blue form, the electron and the proton form. And now you can make code out of it. Morse code is just using dots and dashes, right? It's just using a simple mechanism to say anything. You can do Shakespeare, in Morse code. Yeah, it might take 673 years, but you can do it. And so that's what the universe is doing out of this. That's what light is. Light is just a pattern of the forces, the force, and magnetism is just a different pattern in the force. And electricity isn't really a force, because electricity is really affecting atoms. Electricity only travels through conductors, and so technically, it's not a force. I mean, technically it is a force, I should say, but because the force is always inside of atoms, that is, it's always just changing atoms by changing how much force is in them, it's not a free force. Like the other forces are traveling through space and affecting matter at different locations. They're acting at a distance, where electricity has to act local. Alright, atoms are not solar systems. That was a big mistake. Is this, in my opinion, this is a model they should have fixed a long time ago. The idea of the electron having some sort of motion, that it's moving, a quarter of the speed of light, spinning around a nucleus, is just, I think, a really bad idea, because it doesn't even make sense to the idea of sharing electrons. So, this was something, when I heard it first as a kid, it was just one of those things where you're just saying, hey, I don't think that's the right answer. It just gave you reason to doubt, like, well, do they really, really know what they're talking about? So you have the nucleus of two atoms, and we know the electrons are on the outside. And the idea that this electron is going around and around and around was really dopey. That this would make two atoms stick to each other. Because you're just like, well, the electron's over here. How, why wouldn't this atom just leave? Take my electron with me. I'm gone. I'm just going to drift a little bit away, and we're not connected anymore. It just didn't make any sense that that's how you would share an electron. And that, to me, it seemed kind of, obviously the electron's here and they're sharing it, and it's stuck here, and that's how they're sharing it. It's stuck in a position, they're in a position, and they're sharing the electron, or they're sharing 2 electrons, or they're sharing 3 electrons, And that's how they're bound. They're not, the electrons aren't going all over the place making a mess. And so this kind of model, which would be like a charge model, I mean, we know the electrons are minus, we know this is positive, and we know that the electrons, atoms have more than one electron, and the electrons would be opposing, this attraction force, because to go in requires you to push on the other electrons, so you're kind of stuck in a position, magnetically stuck, charge stuck. And that this model makes so much more sense, it fits, it works, and I just don't know why they're keeping this electron swirly stuff, and somehow it doesn't all fall apart, with electrons doing all of this momentum thing. Really bad idea. So there's no real, you can't point to an experiment that just says it, that shows it. But likewise, they can't either. So you're just stuck saying, you have a choice, a free choice, really, to believe either one. And I would argue there's really nothing the magnetic model of or the charge model of the atom can't explain just as well as the solar system model. And now they've turned it into, because they don't think electrons are real, they don't think the whole universe is real, made out of anything real. And so it can be in multiple places at once, and it's a cloud, and it's, all this bullshit that just, it was bad enough when they had the thing doing this, and then when they started making it, it's not really there, oh, come on. Not really being there isn't going to hold atoms together. I mean, it just really got, so their model is actually really flawed. Compared to a simple model that, yes, they're stuck together because they're sharing something. Anyway. Electrons have no orbital momentum. It's no reason to believe they do. The fact is they can be ejected because they can gain velocity, because they can be hit by a force, and the force, the pressure between the electrons can increase and cause them to move, and move quickly. They don't need to already be moving. I would also argue that one of these statements eventually will be something like, electrons don't have perpetual motion. You can't throw an electron like you throw a wrench in space, and it'll keep going, because electrons don't have any mechanism to allow them to maintain their momentum. They have to have a mechanism to overcome what would be called the drag. That is the fact that the universe is full of radio waves and all kinds of stuff, and the electron would be plowing into that stuff at a higher rate if it has a velocity. So when it's moving, it's hitting more universe, more stuff, and it has to in some way have a mechanism to compensate for that drag. And the single electron can't find any mechanism, it can't make one, but the nucleus of a helium atom can. And so that's a key ingredient to all this, that once you arrange a few electrons and protons together in a minimal configuration of 3 or 4 of them, now all of a sudden they can overcome drag. They'll push harder. The more you push on them, push against them, the harder they push back. Alright, but that's a whole nother, drag is a more complex subject, so it's not on the list yet, because you do the simple stuff first. So, atoms are better modeled as magnetic or electric than gravitational. By electric, I mean charge, so I should put charge in parentheses, because charge is the more elemental function. Charge is what these red and blue things in the animation are running on. That's the most elemental of the functions. And gravity is charge, but it's charge neutralized by the fact that the atoms aren't aligned to create a more blue or more red pattern, so it's purple. But anyway, so charge is negated, but the fact that the stuff moves isn't negated. But that comes up. Alright. Gravity is the consequence of the fact that some portion of the momentum of a force is consumed pushing matter, bits of matter. So by pushing electrons and protons, the force, which moves the speed of force, which is very high, doesn't move the speed of force anymore. It moves the speed of whatever it's pushing can go. And that reduction in the force's speed, while it's pushing matter, is a consumption of energy, essentially, and that's what causes the convergence, the anti-divergence, as the famous Stanford physicist would say. It causes the effect of gravity. That is, more energy goes in than comes out of something, and the only way that can happen is you have to use the energy in some way, because the Earth doesn't store energy. So, and you don't in any, you store energy, but it's a whole different kind of storage. You don't store this nuclear kind of energy. So the fact is your matter, by moving, the electrons and protons, by jiggling around, doing that little jiggling stuff, that's absorbing energy out of the universe. Every time a piece of matter moves somewhere, or has to be moved somewhere, it's taken a little bit of the energy out of the universe. And that's the cause of gravity. It isn't just some magical bent nothing, space, whatever that is. It's not a bent space. Again, another answer that's just so empty. I just don't know how, like, you sat in a classroom, somebody told you this bent space stuff, or maybe you heard it, like on the radio, and you said, well, that sounds weird. And then you went to school, and they finally got to the subject, and then they told you what the secret was. You figured there was something more to the story, maybe. And then when you hear what their actual story is, you're like, what do you mean? So some guy wrote 2 pages on the subject and invented some notion of a bent space that only works, in 2 dimensions, and if you imagine gravity actually, it's supposed to be a theory of gravity, and it relies on gravity to create the gravity well, and it doesn't even make any sense. And then you hear the real story is, no, it's 3-dimensional, and it's really just a convergence, an anti-divergence. It's just the fact that it's just a vacuum cleaner in the center of everything. Well, then you're like, well, what? It's not bent space. It's invisible vacuum cleaners, right? And then you say, well, there's got to be a better answer. This idea of pulling doesn't, pulling on what? What are you pulling on? That doesn't make any sense. But the idea that the universe is full of energy, that there's a ton of these little bits of momentum flying through the universe, and they're pushing from the outside in. And all you have to do is come up for a reason for why more go in than come out. And that's all you have to do. You just automatically have gravity. So just come up for a reason for why more go in and less come out. And the simple reason is because they're using up their speed of light. They're using up their speed of force. They're not going to be able to visit as many places in the universe because they're getting slowed down in their trip. And that's the loss of energy that gravity is a consequence of. That simple explanation works so much better. It's so much more complete. It's so much more rational. I just hard to imagine that you're just sitting there saying, "Oh, but bent space is really cool, and everybody else believes it, so I have to believe it, even though there's really no evidence for it." It really doesn't make any sense. And then you get into the whole idea. I guess, yeah, I should write on here in the list. It'll have to be something like, there's only 3 dimensions. There's no time dimension. You can't bend time because it's not in a dimension. It's not a place. It's not a thing. Okay, time is an event, and it just exists because there is a speed limit. If the little force bits moved instantaneously, then there wouldn't be any time because everything would happen all at once, and it would all happen at once and be over because it was instantaneous. Yeah, obviously there wouldn't be events if there wasn't a slowness to allow for the sequence of events. You can't have a sequence of events if there isn't any time to have the sequence of events in, and the only way you can have time is you have to have something move slower than instantaneous. And obviously the universe has those components, obviously. So it's almost like you're just saying all I'm doing is arguing with traditionalism. I'm just arguing with the fact that you just don't want to change. You know. I mean, but you do change because, well, I do remember in baseball they tried to change the uniforms, and they were doing this, they started looking really doofy, with the half like knickers and shit, and it was really goofy. And but basketball, they completely changed. So it is a strange world where you see this kind of I would have argued that they would never tear Yankee Stadium down, but they did, and they didn't rebuild it like as Yankee Stadium. They built it like some other stadium. And I said that change could never happen. People would never accept that. But fine, go ahead, do whatever you're doing. Totally unnoticed. So it is a weird world in the sense that there's these gross inconsistencies in what traditions people will let go of. But, I gotta say, it's a little bit crazy. Now, see, this gets out of whack because, I think the stuff going in starts to get too, gets a pattern in it, okay? And then the pattern breaks its ability to make a pattern, so you get it disrupted a little bit to get them back into the equilibrium, something like that. I have to work on that part. It's just an inconsistency in the algorithm. It's difficult to create truly random systems without them developing a pattern. Computers aren't really great at doing that, especially when they have to do it quickly. That's asking a lot. Anyway. Alright, so I guess I don't think there's anything else to say. I'm just saying that, why are you clinging to theories that are just, they're just so incomplete and unfinished and they're not explanations. It's not physics. To say the words bent space is not really doing physics. To say bent ether, maybe. But bent space? Come on. It's not even a thing. It's supposed to be it's like saying bent nothing. It should annoy you that you were stuck with that as an explanation. And it should please you that I'm giving you a choice to believe something more physical and real. But anyway, so far that's not the reaction. Alright, energy is momentum, and momentum is weight in a direction. So, I can't, this one is so, another one you're just saying, come on, why do people resist? That they just made a mistake, okay? This kinetic energy, idea of kinetic energy, some kind of special energy, that goes beyond momentum. And then the whole idea that they converted, this simple mv, which, is p, and Newton's equation was just a simple equation that basically just said force equals this mv. And if you want to know how much force per unit of time, Well, then, yeah, you can put units in here, and you can say how much force per second or per minute. But if you don't care about that stuff, then all you're really going to say is how did the momentum change? However the momentum changed, that's going to be the force. The force was an amount of momentum. And that's pretty much all there is here. And energy equals an amount of momentum. And so that's simple continuity, and makes sense. Newton's physics worked. He's good at predicting stuff. Good math, good, solid, simple. Good, solid, and simple. And then they converted it into this. I mean, first they converted it into mv squared and did that for 100 years. And then they decided to put a half in front of it. All right. And it doesn't make any sense, and it creates all kinds of free energy scenarios and paradoxes, and it's too silly. And the bottom line is they had it right in front of them all this time, in the sense that they have these units, they have all this stuff, and it's simple because, gravity is making you have weight. You don't have any weight. You are weightless. People talk about it. You're weightless in space. You don't have any weight, okay, until gravity gives it to you in space. And that's just the truth. And the truth is, though, I can get the weight from any force that pushes me. So I can have a little explosion happen, boom, boom, boom. Over here, I can be sitting in space, and it's going to do the same exact thing that gravity is going to do. It's going to create a differential. That is, there's more energy over here than there is over here, and therefore I'm going to move into the lower pressure, into where there's less things hitting me. Only 3 hit me here, 7 hit me here, I go that way. Well, gravity's doing the same thing to you right now. It's creating an environment where there's 10 little bits of energy hitting you down, and there's only 8 pushing you back up. And that's why you crash into the Earth, and the Earth has to create the extra 2, all right, to rebalance you. Okay, it has to push back, and it can, because it's a whole bunch of pressure it has, because it's got a whole bunch of weight pushing down on it. And the other side's pushing down the other direction. That creates a big giant sphere. That basically creates a giant ground. Okay, a neutral pressure that'll always push back on, little incursions. But yeah, so all you're saying is that the weight is energy, is force, is just depends on the direction you're going. So if an explosion happens, it gives me weight in this direction, and the weight will be just the simple calculation of, well, what's the number of buckets I have to hold this energy, and how much energy can the bucket hold? How high can I fill the buckets? And so my velocity, that's the velocity is the bucket, okay? Mass. Ooh, that's a good drawing. Let's make that bigger. Ooh, I had a little ooh moment. Yeah, ooh. So yeah, I could do it this way to illustrate for the little kiddies. All right, your velocity, okay, is how much stuff have you collected, okay, and your mass is what's making the bucket. Okay, you can't fill the bucket unless you have a mass to hold it. So if you have a little bit of mass, you fill it, with just a little bit of stuff, right? If I only have a mass this big, I can only fill it this much, right? I can only hold little pieces of energy. But if I have a big mass, lots of little bits, I can hold lots of volume of velocity. Well, that's really not the right way to do it, frankly. Because obviously the small bits can have a very high velocity. But you're told that, you're yeah, so, alright, I'll have to rethink that a little bit. Yeah, because the little bits can have essentially, they can be moving very, very fast, each little bit of matter. But anyway, your mass is what makes your velocity meaningful. So to your momentum, it is the combination of the two that create a volume that is your energy. Your energy is how many soldiers and how much energy, how many Did all the soldiers eat their Wheaties? And are they all full of energy? Or did they have kind of a crappy breakfast of whatever? Cocoa Puffs. What's a good energy, frankly? It's the long term versus, Wheaties will get you through the race. You'll win the marathon. But Cocoa Puffs will get you, the sprint. They'll be great for the day. But anyway, so you had some other kind of breakfast, frankly. Whatever. Cardboard. You ate cardboard for breakfast. Well, cardboard's not going to get you anywhere. Okay. So this got a little bit, messed up, but whatever. It doesn't matter. It's all part of the educational process. Tangents and, things that look like wrong turns, but they're actually right turns. It's just you don't realize it yet. So anyway, I think I've made the point. And it's just important to understand. You don't feel gravity because gravity is a nuclear force, a true nuclear force like magnetism. And it's affecting your electrons and protons. It's not affecting your atoms. It's not affecting you. It's affecting the littlest bits inside of you. It's pushing on them. And they're doing the math and figuring out that there's more energy up there than there is coming up from the bottom. And so you're just moving into where there's less energy. All right. Oh, there it is. Gravity is a nuclear force, only directly affecting electrons and protons. Well, I just said that, didn't I? Yes. All right, anyway. So, forces like light never interfere with each other. So this gets into the whole, wave-particle duality. Does that make any sense? Come on. No. So you have to make a choice, and again, it's apparently people want to choose waves for whatever reason, even though all of the math really does indicate vectors. And in some sense, you could argue that, see they do it, they almost get there, and then they break it. So Feynman would say, I could put a surface here, and he would make arguments that to get from here, I can have light do lots of different things. I can have it, here's the light source, here's the detector. Okay, so here's the source, here's the detector, and I'm going to bounce it off a surface. I could bounce it this way, okay, not very likely it seems, and then I can bounce it, this way, and then I can do equidistant, and I can do lots of different ways that would get me, and if I make this a thick surface, then I have to account for the bottom layer, which, the light will move at a different speed through, and so that'll really screw it all up and make it very interesting. But anyway, the point is that Feynman would argue that, it takes every direction, and we get a sum of all of the possible directions. But the truth is it could be something like that. Because all you're trying to do is reconstruct a pattern. You're just trying to get this code of a frequency. The same distance between each unit. And so you're throwing stuff out that has that. And then when it hits the surface, they're all flying in different directions. They're getting scattered in the surface. They're getting scattered out here. So you have all these little bits flying around, and all you're really saying is which paths end up putting these in the right order. That is, they end up with the same, even though they're left at different times, they line up, and they recreate the period, because that's all you really want, is to create the frequency. And so when they're in phase, that is when they're not in places like this in the sequence, okay, then you'll have a photon. But the photon could be made of a piece that came from here. So one of the little bits could have gone there and been here. And then at the right time interval later, a bit, okay, shot here and went here and went here. And that one works because it shows up at the right time. And then one went way over here and then up here. And then that one shows up at the right time. And so that's all you're really doing, is you're just breaking a pattern. The pattern comes out nice and good, but as soon as it hits something, it gets all messed up and bits get scattered all over the place. And what you're really saying is, if I send enough of these things and I break them, I can remake them at a location. I can pick any location and find pieces that'll show up at the right time, and I'll get a certain number of reconstructions. And the more bits that get to me, the more likely I can reconstruct this phase. The less bits that get to me, the fewer reconstructions I can make. So that's the particle model, the one that's never taught as a competing model. So they always just say particle like a photon. This is a photon here. No, that doesn't have a frequency. That doesn't have a wavelength. This doesn't have a photon. This is a photon. So that simple modification to the particle part of the particle versus wave. There's no duality. There's a versus. One is right, one is wrong. And particles work. Particles can imitate waves. Waves can't imitate particles. And it fits the evidence. And so there's certain experiments you could do, so that will be another list. There's experiments that could be done. I brought up the radar one where it makes it kind of simple to just look back. Okay, so all you're really going to say is, look, interference depends on a theory that the forces are interfering with themselves in the space between the source. Okay, you got your source here, you got your target here, and in this space between the two is where they're supposed to be doing all this interfering. Okay, interference is happening. And so if you can just take a place on the target, and so say I have two sources, all right, and now I simply say their theory depends on these two sources, like I said, making these waves and interfering in this space here. Well, if I can pick a location, okay, where it's supposed to be interfered, that is, the light has destroyed itself, okay, the two things interfered with each other, and the photons don't get here anymore. Well, if I can just shield my eye, okay, the looking eye, so I only see one of the sources, this source or this source, so I shield this one from having a vector to my eye, and I can still see this one. Well, then we know it didn't get broken. It didn't get interfered with. It got jammed. All you did was jam the signal like a radio. So I have a radio, and I get zero reception because there's a station in Philadelphia and a station in New York using the same frequency. But all I do is I put a little cone on my antenna, and now I can get Philadelphia, or I can get New York. So they're not really, it's not interference in the field, okay, that's causing the phenomenon. It's the target. That's where it happens. And it's just a matter of signals jamming each other. And so in photons, I would argue it's a little different in the sense that you have actual physical. These things aren't going through slits, so the sources aren't breaking the signal. But with light, you're actually breaking the signal by having it pass through a surface and get scattered. So the signal of ... is getting turned into dot, no dot, dot, It's getting broken. Little bits are scattering in all directions, and you need to reconstruct the pattern out of dots from different sources. So you get a dot from this source as the first dot, second dot comes from that source, third dot comes from that source. That kind of thing needs to happen. So you're breaking photons and then remaking them at the surface. But again, the radar experiment without using slits, even if you use slits, it wouldn't matter, because you're not really breaking them, you're just creating two sources. Photons get broken by surfaces. Radio waves don't. So again, subtle differences in these phenomena. Again, people got to be really careful to make distinctions. It's a different experiment when you have a source, when you create two sources that have the same frequency, And when you take one source and split it into two sources, okay, using a surface to do the splitting. I mean, these are different experiments, frankly. And, you know, they shouldn't make it all, they shouldn't do this loose, it's just like, because it's not just like. It's entirely different, really. In the radio frequencies, the two-slit experiment is jamming. They're just jamming the signal. In light, they're breaking the photons at the surfaces, and they have to reconstruct them at the target. Very different. All right. So anyway, so the idea is that forces don't interact with forces. Forces can't hit each other and change the universe. If they hit each other, they just reflect, which is the same thing as missing each other. You end up with this going that way and this going that way, and it just can't mean anything. So there is no interference between the forces, and there is no interaction between the forces. It's a push universe, and the last line is the, you know, what I'm just saying. The forces push matter, and then matter, by moving, pushes forces. That is, it creates earlier reflections, more reflections. Hands going this way, more reflections to you. Hand goes this way, less reflections to you. So the force is changed by the matter changing its position, and the force is what moves the matter to the new positions. So forces act on matter, matter acts on forces. And that simple idea is the true mechanism. And that's, you know, and frankly, I'm surprised I'm surprised how double your standards are, how unfair they are, in the sense that you're allowing traditional gibberish to hold you back from what is just not conclusive evidence, but substantial reason to believe. There's substantial reason not to believe them, and I've shown it to you in the fact that none of their math really works, and their, you know, some of their proposals, some of their theory is overtly paradoxical. I 100% transferred the momentum, yet I lost half the energy. I mean, silly notions. I 100% transferred the momentum, but I moved buildings and I did all kinds of other work. How could I do all that stuff without using my momentum? I mean, really stupid theory. And still all of this resistance. So, I think that's probably enough. So I gotta increase the number of things on the list. There's all kinds of stuff I probably haven't mentioned. Again, I'll get to the 2 plus 2 plus 2. So there's just two kinds of matter bit, electrons and protons. There are not 400 different kinds of particles. All of what they think are different kinds of particles are just probably electrons at different distances from each other, moving at different velocities. So say if you had a force, a gamma ray or something, and you pushed an electron with it. Well, what if there was an electron in front of it? Well, that one's going to get pushed too. And so now you have two electrons pushed into each other, which makes them sort of springy, if you get the idea. They're almost like a spring. They're going to push into each other. The force between them will be kind of multiplied, but it can't react until you stop pushing them from behind. All right, but as long as you keep this force pushing forward, okay, it's, you know, straight without any divergence in how the force goes, it'll just keep pushing forward through the mechanism of the two electrons. And so that's what a muon would be. And you could go on and on. So all you're really saying is I can call it something else. When the electrons are this close, it's one thing. When the electrons are this close, it's another thing. When they're this close, it's another thing. You could almost just say you could create a 400 of these particles by just pushing electrons and protons as pairs. And what if you had a triplet? What if you actually had a circumstance where you had the electrons, right in a row, and you end up pushing 3 electrons with the same force? You're really not going to be able to know how many electrons there are. It's not that easy to do. We can't follow these things as as single items. We can only watch a whole bunch of this stuff acting. So, it's they're just drawing some wrong conclusions. So that's a whole nother field of physics that I think I could easily debunk. But I can't do it with anything but logic. Experimental results are harder to find. Inconsistencies in experimental results because they require analyzing all of their hadron collider data and why they drew a conclusion about a particle. And what it really has to do is just what kind of energy did they get as an output to their experiment, and their explanation of that energy. And you have to understand their energy formula is mv squared. It's not the right formula, so they're overestimating the energy and underestimating velocities and all kinds of things like that because they don't have the right equation. But that's all crap. So there's two kinds of matter: electron, proton. And they have their own properties. That is, the proton appears to be quite more massive. It's the same size, but it weighs more. So it creates the same charge, the same profile to the universe, but it's heavier. That is, it doesn't push as easy, so it moves slower. That's why it's stuck in the middle. And the electrons are the conduit. They're the yang to the proton's yin. They first create nucleuses, and much like life itself, once you have a cell, and then you shove a nucleus in it. Okay, so matter did the same thing. It first made a nucleus, and then it could collect electrons around that nucleus and create patterns. But it's that simple. Two kinds of matter. The forces are likewise in two fundamental forms. Besides the other patterns, there are 2 colors. There are 2 types: electron force and proton force, and they just have 2 kinds of actions. They can reflect, or they can change color and be diverted. And that's it. And you can make patterns with that simple mechanism. Patterns that look a lot like, that's what an electron and proton would do. If I put electrons and protons into a room, that's what they would do. Okay, so, but you have your little traditions, and like wearing people used to wear, they didn't wear baseball caps, they wore, hats. They used to wear those really tall ones, whatever you call them. She's like, top hats. And you changed. It was okay. No big deal. I'm just asking you, just look at it and see that it's just a silly tradition. The physics is mush. Okay, there's not a big giant pile of evidence and you have to sit there and sacrifice your capacity to reason to change. Okay, it's already saying change, change, change. It doesn't work. Quantum mechanics and gravity, the 2 theories don't even fit together. So there's a huge good reason to say, screw one of them. Well, if you can screw both of them. Fuck it. Fuck them. Okay, you don't, neither one of them was well reasoned. Alright. So I've done my job. So till the next time, when I will get more specific, I suppose, and talk about some particular elements of all of this in some more detail. and blah, 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 blah. So what am I looking for? Probably this button. Alright, so this has been a DraftScience video presentation. Thanks for listening and such. But I'm sorry, until you're doing a little better than just listening, I'm not all that excited.